To make a flag signalling system, we need to move levers or flags into different positions to make a different shape for each letter. But how many different combinations of these lever positions are there? One useful way to solve a problem like this is to draw a table. This lets you work through all of the possibilities in a logical way to make sure you don't miss any of them, or count the same thing twice. We have 2 levers or arms, and we'll start with a simple code system where each one can be in one of 4 positions: up, right, down, or left. I'm going to draw a table with 4 rows and 4 columns. You can go ahead and draw your own table in your notebook. I wonder if you've worked out already why I decided to use 4 rows and columns. Remember, we have 4 possible positions for each arm. I'm going to draw each possible shape we can make using these positions. We'll start with both arms pointing up, and I'll draw that here. In this top row, I'll always keep one arm pointing up, but I'll move the other arm through all of the different possible positions in order: up, right, down, and left. You do the same. Fill in the top row of your table, showing one arm always pointing up and the other arm in each different position going round the circle. Now let's start a new row. This time we'll always have one arm pointing to the right. Like before, we'll go around the circle starting from the top. But we already have a shape where one arm is pointing right and one is pointing up. So I can leave this first column blank and start in the next square with both arms pointing right. Then I'll finish the row by keeping one arm pointing right and the other arm moving around the circle like before. Time to start a new row, and again we'll keep one arm the same, this time in the down position, and move the other one around the circle. We always start from the top, and this time we can leave these first 2 columns blank because we already have both of these shapes. We have one more row to go for our final set of shapes, where one arm will always point to the left, and we've already drawn most of these. We have combined left with up, right, and down already. So all I need to draw here is this last shape with both arms pointing left. So we've drawn all of our possible combinations, and we've used a table to help us work carefully and methodically to make sure we don't miss or repeat any of them. How can we work out how many shapes there are? We can see that there are 4 shapes in the top row, 3 in the next, then 2, then 1. If we add these numbers together, 4 plus 3 plus 2 plus 1 equals 10. So there are 10 possible shapes we can make with 2 levers in 4 different positions. That might not be enough shapes for our code. What if we add in some extra positions in between each of the ones we already have? That will give us 8 possible positions for each arm. How will we find out how many different shapes we can make now? Well, we could draw a table again. Now we have 8 positions. We'll have to make it an 8 by 8 grid. That's a lot of drawing to do. Maybe there's a quicker way to work it out. Let's go back and look at our 4 by 4 table again. Did you spot a pattern in the number of shapes we drew in each row? It decreased by 1 each time. To work out the number of different shapes we can make with 2 levers, we started with 4, the number of positions for each arm, and then wrote the sequence of numbers, getting 1 less each time down to 1. Then we added those numbers together. So if we have 8 positions for our levers, we can start with 8, write a sequence of numbers, getting 1 less each time all the way down to 1, and add those numbers together. Can you add those numbers together in your head? 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. I changed the order around a bit to make it easier. 8 plus 7 is 15. Add the 5 to make 20. There's a 6 and 4 which I know make 10, so that gives me 30. add 3, 2, then 1 to get 6, so a total of 36. And there's our answer. We've done 2 useful things which mathematicians do. We've used a table to help us keep track of our answers and to help us work more carefully and methodically. And we used a simple problem to work out a pattern, which we then used to solve a bigger one.